The second concept from the section is finding out the sum of an arithmetic sequence. Now, what we've done already is we've talked about sigma notation, but there's a real quick way that we can find the sum of an arithmetic sequence if we know the first term and the last term and the number of terms we're dealing with. And here's the result of putting all the two formulas together. We get S sub n, which is the sum of a series that is n terms. It's going to be n times a1 plus a sub n divided by 2. Or you might see it written as S sub n is equal to n over 2 times a sub 1 plus a sub n. So we want to evaluate this notation here, this sigma notation, of 7n plus 1, and we want to go from 1 to 20. So what this formula is saying is if we want to solve this out, we would take our equation and we would say 7 times 1 plus 1 plus 7 times 2 plus 1 plus 7 times 3 plus 1 all the way down to 7 times 20 plus 1. And this first term would be a sub 1, then we would end up with a sub 2, all the way down to a sub 20. Now in our previous section, if I wanted to solve out the series and find the sum, I would need to find all 20 pieces and then add them up. However, with this new formula, we can just find the first, we can find the last, add the result together, and then multiply by the number of terms and divide by 2. Just apply this formula. So we can see here, if I solve for a sub 1, 7 times 1 is 1, plus 1 is 8. So a sub 1 is 8. Here, a sub 20, 7 times 20 is 140, plus 1 is 141. And I know n is equal to 20, the number of terms in my series. So then what I do is I take S sub n, which we know is going to be n times a sub 1 plus a sub n over 2. And we know we want to find the first 20 terms. So 20 times 8 plus 141 over 2, which is what we've got right there. And that ends up to be 1490. Now I can do the same thing here with the partial sum of an infinite sequence. I just need to find the first term, the last term, and then apply to my formula. So here I see my partial sum is 2, 5, 8, 11. I know my d is going to be 3. I know a sub 1 is going to be 2. And I want to find a sub 15. I also know the number of terms is 15 that I'm dealing with since I want the 15th partial sum. So how would I find that out? Now I know we could write down 2, 5, 8, 11, 14, 17, 20, and we could list out 15 numbers. But what if I wanted the 2,643rd partial sum? You don't want to write out all those numbers. So let's go through this mathematically to figure out a sub 15. The way we do that is we use the formula we looked at in the previous section. We know a sub n is equal to a sub 1 plus n minus 1 times d. So if I want the 15th term, I know my starting value is 2, the number of terms is 15 minus 1, and my common difference is 2. So a sub 15, when I solve all that out, is going to be 44. Now that I've got my starting value, the number of terms, and my ending value, since I know a sub 15 is going to be 44, I can plug into an equation. S sub 15 is equal to 15 times 2 plus 44 all over 2, which gives me the summation of the first 15 terms as being 345. The last example is a word problem, a story problem, and it's the exact same approach that we're going to take as we did in the previous problem. But this time we're talking about the number of seats an auditorium has. So we know the first row has 30 seats. Each row has 2 more seats than the preceding row, and there are 40 rows. So I know a sub 1 is 30, a sub 2 would be 32, a sub 3 would be 34. And my question is, what is a sub 40 going to be? Because if I want to take the sum of those 40 rows, I need to know my first row, how many seats are in it. I need to know how many rows are in the last seat. And then I need to figure out the number of rows that there are, which I already know that there are 40. So once again, I could write out all these numbers and figure it out, but let's use our formula. A sub n is equal to a sub 1 plus n minus 1 times d. So a sub 40 is equal to 30 plus 40 minus 1 times d, which is 2. So a sub 40 is going to be 108. So there's 108 seats in the 40th row. So now that I've got my starting value, which is a sub 1, my ending value, which is a sub 40, and I know the number of rows, I can use my summation formula. So S sub n is equal to n, a1 plus an over 2. We want the first 40 terms, and we know the first piece is 30 plus 108 over 2. So S sub 40 is 2,760. So there's 2,760 seats in the auditorium.